Hello everyone, so we're on 2-3 for today's lesson. So this lesson is about linear functions. Linear functions. Okay, what do you mean by linear function or linear equation, and how does it look like? So first thing is every degree 1 function. So degree 1 function is called a linear function. Okay, now the question is, what do you mean by degree? So degree is actually the highest exponent of a function. So let's say I have y is equal to 3x plus 5. Okay, what is the degree of base x? So this x, what's the exponent of that? So it's 1, so degree 1 function is called linear function. Let's say I have y is equal to 3x squared plus x plus 5. Okay. For the degree part, you always have to look at the highest exponent. So what's the highest exponent for x this time? It's 2. So is this linear function? This is not y because degree is not 1. The highest exponent is not 1. So degree 1 function is always in form of like this. mx plus b means x has exponent of 1. That's the first thing you needed to know. Next, why do we call this linear function? So if you look at closely, this linear function, the name itself has something in it that makes it linear function. It says line. So linear has line in it. It means when graph, it always going to give you a straight line. So every time you graph a linear function, it's always going to be a straight line. So something like this, it could be like this, could be a vertical line, could be a horizontal line. So it's going to be a straight line every time you graph, okay? So next one. The first concept in this function is about slope. Okay, so what is the slope? What do you mean by slope of a line? So slope is basically, if I just say in simple words, it's actually the steepness of a line. Steepness of a line. But if you want to get kind of actual definition, so I would say, so slope is basically, it's actually the ratio of the vertical change over the horizontal change, which is nothing else. It's actually, a lot of you guys might know this, it's called the rise over run. So from one point to another, how many units you go up or down, and how many units you go right or left. That's how we find slope. So here's an equation to find slope. So it's normally slope, m represents the slope of a line, and it's rise over run. And how do we get rise and how do we get run? So let's focus on that. Rise is when you look at the vertical change, means you look at the y-axis. So y2 minus y1 gives you the rise part of that line. And how do we find run? So if you take x2 minus x1, that's how we find run, or the horizontal change between any 2 points on the line. So let me show you an example here. I actually have 3 different ones, and I will actually interpret at the end. So let's look at the first example. I have -3, 7. That's my first point. Second point is -2 and 4. All right. First thing I would do is I'm just going to label these coordinate points. Let's just say this is x1, this is y1, this is x2, and this is y2. All right, doesn't matter which one you set it equal, it's okay. So I would start off with first one as x1, y1, second point would be x2, y2. Now let's find the slope. So I would do y2 minus y1 over x2 minus x1, plug it in. 4 minus, so you gotta watch out for signs. So 4 minus 7 over -2 minus, I would just put parentheses for negative numbers. And here you go. Now let's simplify. This negative. 4 minus 7 is -3. -2 plus 3 would be 1. And the slope is -3 over 1, or just -3. Okay, what does it mean by -3? Later on, you know what's going to happen, and once you graph it, since it's a negative slope, I know the graph's going to be going down from left to right. That's what negative slope means. It would go down by 3 units and it would go to 1, like go over by 1. That's what it means. Down 3 because it's negative number, and over 1 because the bottom number tells you the horizontal change. And that's how it's going to look like at the end. I'm just going to give you kind of like idea what it means by negative or positive slope. All right. How about part B? There's another example. I have 3, 1, and -4 and 1. All right, so still, I'm going to use the same equation, but I'm going to try skipping that step of plugging it in. I'm just going to plug in right away. Y2, which is this. So 1 minus 1 over -4 minus 3. Simplify. 0 over -7, and 0 divided by any number is always 0. All right. How would you interpret something like this? So let me show you the graph. So there's no change for y, means there's no vertical change. It's just the bottom number that changes, right? So it means the only change I see in this graph is the horizontal change. There's no vertical change. So once I plot it, so my graph's just going to be a horizontal line. That's how the graph's going to look like. Why? Because it's not going up and down. It's just going sideways. So that's how zero slope's going to look like once you graph. Part C. I have 7, -3, 7 and 1. So let's find the slope. Y2, which is 1 minus -3. 7 minus 7. I have 4 over 0, which is, any number divided by 0 is always undefined. Okay, but now the question is, how would you interpret this on graph? What do you mean by undefined? So just like the last example we did, we just looked at the change. So this time, I see a vertical change and there's no horizontal change. Means this line is not going sideways at all. It just keep going up and down forever. So how would the graph look like? So finally, the graph just going to be a vertical line like this. So that's how the graph's going to look like, okay? So positive, negative going to be going up, down from left to right. Zero slope is a horizontal line, and undefined slope is a vertical line. Okay, now let's move on to next example. Example number 2. So now we have how to write linear equations. So we're going to be learning about writing linear equations. How do we write that? Okay, so you needed to know 2 different types of linear equations. So there's first one that's called slope-intercept form. And the other one is called standard form. How does each one look like? So let me show you that. So slope-intercept, okay, it looks like y is equal to mx plus b. And standard form is ax plus by, and it's equal to c. Okay, I know it might get to look scary, like what is that? Well, what about all these variables in there? Trust me, pretty simple. So when I say slope-intercept form, what we need is, what do we need to write this type of equation? So basically, it's just the name, literally the name telling you what we need. So we have to have slope and the intercept. So you have to have the slope, which is this m in this equation, and you have to have intercept, which is the y-intercept. You have to have y-intercept, so which is this b. So if you have both of these given in the problem, then you can just plug everything in and you can write down the equation. And standard form is nothing else. It's the simplified form of the slope-intercept form. If you just simplify slope-intercept form, it would take you to standard form. So basically, you just have to get x and y both on the same side. So both on the same side. So if you just write, or you bring it like x and y on the same side, that's what standard form is going to be. Right? Okay, now let me show you an example, and I hope that would make more sense to you. So let me bring in a picture, because that's what you needed to know. So photo library, and I have the last one here, this one here, and done. Okay, so let me show you first example here. So first one is, it says you have to write an equation of each line. What we know is the slope and the y-intercept. So you already know the y-intercept is, it's always going to be the number itself here, -3. So I know the equation is mx plus b. So it's literally plugging in the numbers. For m, I would substitute this m with the slope, which was 1/5. And the y-intercept, which is -3, I would plug that in. So y would be equal to 1/5x and -3. That would be my answer. That's how we do that. Okay, part B is slightly different. I still have to write slope-intercept form, but again, what do we need? You have to have the y-intercept number and you have to have the slope. So y-intercept, how do we do that? Y-intercept means the point where the graph or the line intersect the y-axis. So let's try locating that y-intercept. Y-intercept would be the point where the line intersect the y-axis. So what is the number? It's 4. And we need the slope. How would you find the slope? So pick any 2 points on the line. So let's say if I pick this point and this point here. Try to keep those points exactly on the corner of each box. Otherwise, you don't want to deal with decimals. Nobody wants to, right? So I would pick any 2 whole number like on the edges of each corner. So, and then from here to here, I'll check what's the vertical change and what's the horizontal change. For the vertical change, I know from 4 to 1, how many units we go down. So it's 1, 2, and 3. So we go 3 units down, and how many units over? So it's 1 unit over. So the slope would be -3/1. If you don't like this way, you could still do this equation, pick any 2 points, plug it into the equation and find the slope. You could do that. And lastly, I need to write down the equation. So my equation would be y is equal to, what's the slope? -3/1x. And what's the y-intercept? It's +4, and here you go, I'm done. So that's how we deal with this, okay? Now I have another example. So now let's move on to next example. How do we write standard form or slope-intercept form from standard form? Okay, let's say if the equation is 5x minus 4y and it's equal to 16. Is it slope-intercept form or is it standard form? It's standard form. Why? Because I see x and y both on the same side. How would you write slope-intercept form from here? Okay, so for slope-intercept form, it's nothing else. You just have to make this equation look like this, which is technically kind of solve for. You just have to solve this equation for y. So you gotta solve this equation for y. So get y by itself. How would you do that? Let me pick a different color. Oh, wait a second. So how would you get y by itself? So this is the variable I need to get it by itself. I would take away 5x both sides. So it's -4y. It's equal to, I would keep the x term first. Please do so all the time. Otherwise, you're going to get confused later on. Finally, I see -4 getting multiplied by y. So I would divide by -4. And when you divide by this number, make sure you divide every single number by this term or this number here. So -4 is going to get cancel out. So I have y left here. So negative, make sure you simplify the signs. Negative divided by another negative would become positive. You can simplify the numbers. I would keep it the same. So 16 divided by -4 is -4. So that would be my slope-intercept form. Now, if I ask you to find the slope and intercept from the equation, like let's say I have -3/4x plus 1/2y, and it's equal to -1. Is it standard form or slope-intercept? It's standard form. Why? Because again, I see x and y both on the same side. Let's try making into slope-intercept form. Okay, so I would get y by itself, so I would add 3/4 x both sides. I see 1/2y, and it's equal to, again, I would put the x term first, and plus 1. Finally, how would you get rid of this 1/2? Remember, you can multiply by the reciprocal. I would do that. So make sure you multiply every single one by 2. So this one's going to get multiplied by 2 over 1. So is this. This is y. So this becomes 6 over 4x, and this is 2 over 1, or just 2. Lastly, try simplifying fractions if it's possible. 6 divided by 4, reduce it by 2. So I know the slope is 3 over 2. That's the slope. And the y-intercept would be 2. Or I would put 0, 2. Why? Because this is the point where the graph intersects the y-axis. So this is how we write it. Okay? And the last one is, how do we graph? How do we graph linear functions? Let me bring in a graph here. So grid, and here you go. Here you go. It would be easier. So first step, let me actually put up an equation here. Y is equal to negative 2x plus y, and it's equal to 1. So your first step is to change the equation into slope-intercept form. So you need to write the equation in slope-intercept form. In slope-intercept form. If it is, then there's nothing you could do. So right away, just start plotting it. If it's in standard form, make it into slope-intercept form, and then start plotting. So on this side, I would graph, and on the other side, I would just write down the steps for you. Okay, so first thing you have to, oh my bad, y it's equal to, just a second. Okay, first step, I would actually change this one into slope-intercept form. Wait a second, why does it look, it's negative 2x plus y is equal to 1. It was equal to 1. This thing is not there. Okay, so let's make it into slope-intercept form. I would add 2x. So y is equal to 2x plus 1. So now y is already by itself, so this is my slope-intercept form. Now, next step. You need to start off with plotting y-intercept. So plot the y-intercept. Plot the y-intercept. Since it's the y-intercept, means it has to be on the y-axis. So keep in mind. So it's 1, so means this is where I need to plot my first point. Okay, almost there. So now you need to use the slope to find the next point. To find the next point. Okay, so we already have the y-intercept. So what is the slope? It's 2. I'm actually going to write it in a fraction. It would be easier to see rise over on. It's 2 over 1. So from this point, I would go 2 points up and then to the right by 1. Okay, so let's go 1, 2, and over 1. This is my next point. Let's take another point. I would go 2 up and over 1. That's going to be my next point. Okay, let's say you want to take a point in opposite direction. So again, I would go back to my starting point, which is the y-intercept here. So if you want to work backwards, then I would go down 2 and to left by 1. I could take another point, down 2 and left by 1. And once you have all those points, just connect. Let me bring in a ruler. So if I bring in a ruler here, and if I could, oops, here you go. That's how the line's gonna look like. Here you go. So now I could actually erase these things here so that you can actually see the graph. Oops, my bad. Here you go. So that's how the graph's going to look like, all right? If it's already in slope-intercept form, there's no need to change that. Just start from the y-intercept and then go from there, okay? I can show you one more example, and that's going to be all for the day. So let's say I have 4x minus 7y, and it's equal to 14. First step, change it to slope-intercept form. I would subtract 4x both sides. Negative 7y, negative 4x plus 14, divide by negative 7. Finally simplify, I have y, so make sure you simplify. Negative, 4 divided by 7x, 14 divided by negative 7 is 2. Okay, negative 2. Now let's plot. Okay, what's the y-intercept? It's y-intercept is negative 2, so I would start from negative 2 down here. What's the slope? So the top number is positive 4. This is your rise, and this is the run number. So from this point, I would go 4 units up. 1, 2, 3, 4. And over, it's always to the right side, unless you're going backwards. 4, 5, 6, 7. All right, you can take another point if you want it, but I'm just going to take 1 point backwards. I would go down 4. 1, 2, 3, 4, 5, 6, 7. Here you go. And finally, if I connect all 3 points, my line's going to be, here you go. So that's how the graph's going to look like. So lastly, you can verify your graph. How do we verify our graph? So if the slope, which is the m number, if it's positive, the line would go up. From left to right, it would always go up. From left to right. If the slope is negative, then line would go down all the time. From left to right, line's gonna go like this. Here you go. And yeah, that's pretty much all you needed to know. So thank you for watching. Bye-bye.